Well, that leads me to my next question, and many of us think that all of the research and everything's taken place here in Philadelphia, but what is going on around the world?
We have really been blessed with wonderful collaborations that have spawned from this discovery. And I think we knew intuitively that this was going to happen, that there were going to be laboratories who would be very, very interested in working with us because their areas of expertise were such that they didn't know that this gene was involved in FOP, that they may have been researching either this gene or pathways involving this gene and didn't know of its association with this catastrophic disorder of FOP. And so that exactly has happened. There are other labs who are working more independently on it as well. Once a discovery is made, it's out there. And I think one of the tragic things would be that if you discovered something and nobody was interested in it. So immediately we knew that when the gene was discovered, it would open up areas for other investigators around the world to be able to tap into this deep, deep, profound source of knowledge that would help solve this problem. Some of our really outstanding collaborations around the world have been with people who are working with various types of animal models in FOP. We're working with individuals, a particular individual who has an amazing insight into not just the molecular structure, but the atomic structure of the FOP, of the protein made from the FOP gene. That will be very important to understand the X-ray crystal structure of that protein, so that the medicinal chemists can modify molecules that look promising to make them into better and safer drugs. We also have a wonderful collaboration with a scientist at Vanderbilt University who has discovered a new class of molecules that looks promising in inhibiting the FOP gene itself. It's not yet a drug, but it does have effect. It does have promising effects in slowing down and in stopping extra bone formation. Whether or not it'll be safe and effective in patients depends upon further studies that need to be done and modifications. So again, our collaborations are really an extension of our core laboratory, which are looking at mutations. We have collaborators in Berlin, in Saitama in Tokyo, Japan, at Baylor University, at Argonne National Laboratories, at Brown University, at Vanderbilt University, and at the Max Planck Institute for Molecular Biology in Berlin, and other collaborators around the world as well. Everyone's welcome, and as I said, there's others who are working more independently on this. I think the bottom line is that the tools are now in place for the field to move rapidly, I hope, to eventually turn what is a set of important discoveries into something that's useful and beneficial, that can change the lives of patients and end what Jules Rosenstern said back in 1918. He says, it's about time that we unveiled this problem and solved this embarrassing mystery. And I think we're on the threshold. We're not there yet. We still have a lot more work that needs to be done. I think the more we work collaboratively, the faster we'll be able to get there. And hopefully in our lifetimes we'll be able to do that. We'll be able to, it's my dream someday to be able to sit down at a desk and write a prescription, hand it to a parent or a patient and say, take this pill or this liquid, twice a day. You'll have to take it every day. And maybe turn what is now a catastrophic disease into nothing more than an inconvenience.